All right, we are looking at the second half of Chapter 8 today, starting out with Section 8.4, where we looked at simplifying, multiplying, and dividing rational expressions. In order to simplify it, what do we have to do? What's our first step? Factor it. Yes, factor everything. So what could we factor for the numerator? What could we do? We could take a 2 out. If we factor out a common 2, we have an x squared minus 9 left. How does that factor? All right, so the numerator becomes 2 times x plus 3x minus 3. Okay, denominator. Can we factor anything common out? All right, then we have to go to factoring a 2x squared. So we're going to have a 2x and an x. Needs to multiply to be 3, but add up to 7. What could we do? Does that work? All right, insides we get 1x, outsides we get 6x. All right, so that works. Now, before we try to reduce any common factors out of here, we want to list our domain restrictions. All right, what is it that x cannot equal? Okay. So we're looking at the denominator. What would make each of those factors equal to 0? All right, so we have to restrict -3 and -1/2. Now we can look for common factors. There is an x plus 3 in the numerator as well as the denominator, so we could reduce those out. Anything else? Can we reduce the 2's at the beginning? No, why not? Okay, so in the denominator, it's a 2x plus 1 quantity, right? We have to treat that as a whole quantity. If we could have factored a 2 out of it all, then we could have reduced it with the 2 on top. But in this case, that's all we can do. So final answer is 2 times x minus 3. And denominator 2x plus 1. Okay? And as we went through this chapter, we've said you can just leave it in its factored form like that. But keep in mind, we have a final exam coming up, right? That's multiple choice. If I'm looking at that multiple choice options and I don't see that, might it have been entered as 2x minus 6 for a numerator, where I distributed the 2 in? All right, it's an equivalent form. Okay. How is question 2 different? Yes, I have 2 fractions now, right? 2 rational expressions. I'm being asked to multiply them. Do I need a common denominator to multiply? No. So my first step is same as it was in the last question, right? Get everything factored. All right. What could we factor for the numerator in that first fraction? We could take an x out. Okay. What would be left? Good. Denominator, how does it factor? I heard x minus 4, x plus 1. Does that work? Okay. In the second fraction, numerator, what can we do? Take out a 2. We are left with an x plus 1. Denominator is 2 times x. It's just a monomial. There's nothing to factor. All right. Looking for domain restrictions. What is it that x can't equal? For this one, can't equal a 4. For this one, -1, and here, 0. Okay? Looking for common factors that we could reduce. What do you see? Okay, I heard x plus 1s. Okay, starting with the 2. I heard someone say 2. Can we reduce these 2's? Yes. In this form, they can be reduced. Can we reduce that x with that x? Yes. So, simplified answer now would be 3x plus 1, all divided by x minus 4. Okay. Question 3 is a division problem. What's the one different thing we have to do for division? Yeah, we need to multiply by reciprocal instead. So can we factor this as we flip that second fraction, as we take its reciprocal? All right, let's factor as we go. So x squared plus 7x plus 10 would be x plus 2 times x plus 5. X squared minus 4 factors into x plus 2, x minus 2. Now we're going to multiply and we're going to flip these as we go. So this becomes the numerator, numerator becomes the denominator. What is the numerator now in its factored form? X squared minus x minus 12. Good. X plus 3, x minus 4. Okay. Denominator now is an x squared plus 8x plus 15. Factors into, thank you. All right. Domain restrictions. So again, I'm going through each piece. The first one here, x can't be a negative 2 here, it can't be a 2. All right, so plus minus 2. Over in this one, x can't be negative 5. X can't be negative 3. Am I done? No. Where else do I have to look? Yes. I have to look up here. X can't be negative 3, which I already listed, and x can't be a 4. I have to include those because that used to be the denominator, right, before I took the reciprocal. All right, common things that we can factor out. Okay. X plus 5s, x plus 3s. So final answer would be x minus 4 divided by x minus 2. All right. Any questions on simplifying, multiplying, dividing? All right, that was 8.4. Shifting now to 8.5. This is where we were doing our adding, subtracting, and simplifying those complex fractions. What's different about adding and subtracting compared to the things we've just been working on? Yes, we need a common denominator. Do we have a common denominator? No. The only way we can get a common denominator is through multiplication. We can multiply top and bottom, numerator, denominator, by the same thing. All right? So what would the common denominator be? What is it that I'm trying to get this to look like? Yes, I need an x plus 2 and an x minus 4. So the first fraction is missing what? So if I multiply the denominator here by an x minus 4, I have to do the same thing to the numerator. What does that turn into? Okay. Looking at the second fraction, what's missing on this one? The x plus 2. All right, distributing, I get what? 2x squared plus 4x. And it says that I'm supposed to be adding those, right? Adding those two fractions together. So what I need to do now is simplify all the numerator pieces, right? Combine any like terms, get that cleaned up. So I end up with 2x squared. My x's, when I combine them, I have 7 of them, and a negative 12. My last step would be to try to factor that numerator to see if there's anything I could reduce out. In this case, it doesn't factor, so we're done, but we would want to check for that. All right, question 5. Do I need to multiply the first fraction by an x minus 5 and the second fraction by an x squared minus 25? No, why not? Yeah, if I factor that first fraction, I already have one of my factors that I have in the second fraction, right? They already share the x minus 5. So to get these to have a common denominator, this one needs the x plus 5. All right. Multiplying through. We now have a common denominator of x plus 5 and x minus 5. I didn't have to do anything to the first fraction, so it's still a plain 7. The second fraction's numerator becomes what? Two x times x. 2x squared, and 2x times 5. 10x. But I'm subtracting all of that, correct? So I'm subtracting the 2x squared. I'm subtracting the 10x. If you find that you forget that kind of thing, change this minus sign into addition and put the negative with the 2x. Then it'll be easier to see when you distribute it in. Okay? Combining like terms, we don't have any actual like terms in the top, but we could put it in standard form. So, negative 2x squared minus 10x plus 7, all divided by x plus 5x minus 5. Questions about that? All right. Our second part of section 8.5 was simplifying complex fractions. We had two different methods. One method was to get the whole complex numerator into a single fraction, get the whole complex denominator into a single fraction, and then multiply by reciprocal. That's fine to use. It's a method that works. However, we learned a new method this year where we multiply numerator and denominator by whatever the LCD is, that common denominator. So if I look at all the denominators in this problem, there's a 1 under there, there's an x here, there's a 1 there, there's a 2y there. If I were to get all of those to be common, I would need a 2, an x, and a y. Yes? So I'm going to multiply the whole numerator by 2xy, the whole denominator by 2xy. By doing the same thing to numerator and denominator, I've really just multiplied by 1. Okay, so I haven't changed it. It looks different, but I haven't changed its value. 2xy times the 3. We get 6xy. 2xy times 2 divided by x. Picture this. 2xy times 2 divided by x. What happens? The x's drop out, and we get 4y. Looking at doing the same thing in the denominator. 2xy times the 4 would be 8xy. What do we get when we distribute that 2xy to the negative 1 divided by 2y? Just an x, what sign? Yep, so minus an x. Okay, now, that's done. That's as simplified as I can make it be. I can factor. In the numerator, I could take out a 2y. In the denominator, I could factor out an x. But there's nothing common that I can reduce out. Does that make sense? Okay. I do need to check for it, though. If there was something common that you could get rid of, you'd be expected to do that. Okay? All right. Looking at our last section, 8.6, we were solving rational equations. Right? I've picked out 3 different types. In the first one, we have 2 different fractions on the left side equaling a constant on the right. The fastest way to solve these types is to multiply through by your LCD. What would be the common denominator in this one? Yeah. So let's picture multiplying the whole thing by 10. 10 times x divided by 2 becomes what? Okay. 10 times x divided by 5 becomes 2x. 10 times 7? And now we have just a nice linear equation. 5x plus 2x is 7x. It equals 70, which means x would have to be 10. Okay? Let's go down to number 9 next, and then we'll go back to 8. Question 9, what would our common denominator be? An x squared, yep. So let's multiply through by an x squared. X squared times 1 is x squared. X squared times 2 divided by x squared is 2. X squared times negative 1 divided by x becomes negative x. All right, now notice on this one, we have a quadratic equation, right? An x squared. We're going to get everything to one side so we can factor it. I'm going to add the x to the left side. I'm going to subtract the 2 to the left side. It now equals 0. Make sure you write equals 0 because we cannot factor and solve it without it having an equals 0 there. What kind of factors do we get? All right. So possible solutions. X could be negative 2 or x could be positive 1. Do either of those create problems when I plug them back in? We typically are just looking at the denominator, right? Would either of those make a denominator of 0? No. So they should be fine. If I had some time after my test, I would certainly try them, plug them back in and make sure they really work. But the big red flag should be popping up if you get a solution that when you plug it back in, it creates a 0 in the denominator. Those are those extraneous ones that we have to make sure and eliminate. Okay? All right. Looking at question 8. I held off on this one because it's a little bit different in that it's a single fraction equal to a single fraction. What do we call those? Fraction equal to a fraction. Proportion. Yep. How do we solve a proportion? Okay, now, here's why. Don't cross multiply yet. I want you to think if we were going to solve this using the same techniques we've just been doing on the other two, we would multiply by a common denominator. What is the common denominator for this one? X plus 2 times x minus 5. Okay? Well, picture now multiplying these to the left side. What drops out? The x plus 2. So we have a 3 and an x minus 5 left. Yes? What drops out on the right-hand side? The x minus 5. So we have a 4 times an x plus 2. That's the same thing you get when you cross multiply. That's why cross multiplying works. Okay? That's what we're doing. Distributing. We have 3x minus 15 equaling 4x plus 8. If we subtract 3x to the right-hand side, we have 1 left. If we subtract an 8 over to the left side, we get negative 23. No issues with it getting us a 0 in the denominator? What would be the two solutions we couldn't use in this one? Negative 2 or 5? But we didn't get those, right? Okay. Our last question deals with a mixture problem. Now, we've given you the setup for it, but we're going to talk through how you would create it if we don't give you that formula. Okay? So, for all of our mixture problems, we typically start out with some amount, usually milliliters, liters, something like that. All right? Some amount of a liquid and some kind of concentration. It's usually in the problem given as a percent, but we convert it to a decimal. When I do that, when I take X milliliters times a certain percent, I'm basically saying how much of that liquid is pure saline in this case, or pure sugar, or pure acid, or whatever the issue is. That's telling me how much saline I have in the first quantity. Then I add to it another amount at a different concentration. So again, I'm trying to figure out how much saline is in that piece. So adding those together, I now have the total saline in my combined mixture. Okay? I divide by the total volume. That total volume is going to come from this amount plus that amount. Right? That's my total amount. and it should equal the final concentration, whatever you were trying to get to. So your mixture questions are always set up that way. In this case, we are being told that we have two different concentrations of saline. We have a 4% solution and we have a 3/4% solution. We are trying to combine them to create a solution that is 0.9%. So we're taking strong in relation to the other one, 4%, combining it with a 3/4% to try to dilute it down to a 0.9%. Okay? It says we have 100 milliliters of the 4% solution. So in this case, we are given 100 milliliters, 4%. That's this part. Okay? We are adding to it an unknown amount. We do know the concentration. We are diluting it with this 0.75% solution. So we have X milliliters that's being multiplied by its concentration. My total volume is the 100 milliliters I started with plus the X milliliters I just added to it. Okay? And I want it to equal what? The 0.9%. Now when we dump that in, remember you have to convert it to a decimal, right? So 9/10 or 0.9% is what? What is it? 0.009 equals 100 milliliters of 4% plus an unknown amount of the 3/4% divided by total volume, 100 plus X. How would we solve that? What's your first step? So can we multiply the 100 plus X to the left side? Okay. All right. Distributing. Multiplying by 100 moves my decimal 2 places. So I have 9/10 plus 9,000 X. Multiplying, what's 100 times 400ths? 4. All right, now I need to get X's to one side, constants to the other. So if I subtract these X's over here, I end up with, yes, 15 10,000ths, equaling 4 minus 0.9, 9/10, or 3.1, 3 1/10. What do we get when we divide? All right, so roughly 0.7. And what units would we put on that? Milliliters. Now, is that reasonable? We are starting with 100 milliliters of a 4%. We're trying to dilute that all the way down to a 0.9%, right? Less than 1%. We're going to have to add a fair amount of liquid. Yes? Okay. Questions on the mixture problem? All right, so finish up your review packet. Test is tomorrow.